Good morning, everyone, and welcome to the Developer Day here. Let me share my presentation, actually. One moment. Like this. So welcome to today. And first of all, we have just some rules here. So if you want to follow our code of conduct, you can look at the bit.ly. But basically, it is, maybe common sense there, but beware of others, be friendly and patient, be welcoming and respectful, and be open to all questions and viewpoints, be understanding of differences, and be kind and considerate to others. And we are actually donating to the National Museum of Computing. So please have a look at this URL if you want to give your donation. And we would also like to thank our sponsors, because without them, we wouldn't be able to kick off a day like this. And important also, share on social media. So this is our hashtag DDD2020. And you can also follow us on Developer Day and enjoy your day here. So before we start, I'm just going to fix one thing. So the topic here for today is affective computing, and that is how can we bring humans and machines closer through emotions. And just to give you some settings here, just imagine that you have bought the latest technical gadget and you've taken it home and you're very eager to get it started, but then you can't really get it to work, and you wonder what is happening here. I should be able to make this thing work. You try and you try again, but it doesn't really work, and then you search on the internet, on YouTube, on tutorials, and it still doesn't work. And then finally you actually have to open up the manual. But even though you use the manual, it doesn't work. So what do you do then? Then probably you want to try to get in contact with the company. So you're looking on the web and see, maybe you want to find a telephone number, but there is none. But actually there is a chatbot. So you start chatting with this chatbot and you try to explain the problem, but the chatbot just doesn't understand you. He just sends you some standardized messages back here, and you get more and more irritated. And finally, you just want to take your PC and just throw it out of the window. So what is the problem here? Well, the problem is that the chatbot or the machine learning algorithm, he doesn't understand you. He doesn't understand, your feelings or your emotions. And that's a big problem here. So, but now we're in 2020, and there are actually technologies so that we can detect emotions from our users, and we can build services and products that are much more user-friendly than what they were before. So that is what this talk is going to be about here. Before we start, I'm just going to give you some short background information about me. So I'm working as a manager for AI and big data at Miles, a Norwegian consultancy company. And my background is in human-machine interfaces for process automation and robotics. And my educational background is a master's degree in electrical engineering. And I also have a master's degree in behavior science. And I'm quite involved in the local user community here in Oslo. So I'm part of the Norwegian.net user group. I'm also part of Oslo AI. And I am a Microsoft AI MEP. And I would also like to say a couple of words there about AI 42, which is a new initiative started by me and a fellow AI MEP, Eve Pardy. So what we're doing is we're starting up an online AI school. So please follow us on Twitter. So we're starting up here in January. And you can see my social media links here if you want to get in touch. Now over to affective computing. So what is affective computing? A short explanation here is that this is the human side of artificial intelligence. And if we want to have a little bit longer definition, we can say that this is the study and development of systems and devices that can recognize, interpret, process, and simulate human effects, which is emotions. So basically it is how can we use emotions in order to have a better interaction, both with machines, but also with ourselves, human to human. First, in order for us to understand this better, we first need to get some basic understanding into what is an emotion. I'm going to give you a quick introduction, what we know about emotions from psychology here. So there are three different types of concepts here. One is called emotions, and they are fast automatic responses, and they are also temporary, and it's a way for us to react to stressors. And emotions, they are common to all people. Then we have feelings, which is where we need to involve our cognitive awareness. That means that we are aware of the environment and the emotion. And this also involves the thought process, and this is much more long-lasting. And finally, we have affect and mood, and this is if we mix feelings and emotions together. And this is complex and could also be long-lasting. So now I'm going to give you a quick introduction to some theories of emotions that we've had throughout the history here. So I'm going to go through the James Lange theory of emotion, the Canon Bird, the Schacter-Singer, and Lazarus theory of emotion. Now, our first theory of emotion is from the 1880s. So what they said here was that when we see an external stimuli, then this will lead to physiological reaction, and our emotional reaction will be dependent on how we interpret this physiological reaction. So, for example, if you're out in the woods and you see a grizzly bear, you will have a physiological reaction. Your body will start to tremble and your heart will start to race. And according to James Lange, they say that we interpret this physiological response and we conclude that we're frightened. So it means that you're not trembling because you're frightened. It means that you feel frightened because you're trembling. And what this means is that in order for us to experience emotions, we need to be able to feel it physically. But that is not the case if we think a little bit more about it. So then there came a challenge to that theory in the 1920s by Canon Bird, and they said that we feel emotions and our physiological response simultaneously. And in the brain, the thalamus will send a signal which will result in a physiological reaction. So you see a snake and then you're afraid and begin to tremble. And people experience the same physiological response to different emotions. So for example, sweating and heartbeat and respiration, they are all common to both fear, excitement, and anger. Then we come to the 1960s, we have something called the two-factor theory of emotions, or the cognitive theory of emotion. And in this theory, we focus on the interaction between two different factors, the physiological response and our cognitive labeling of that response. So an example here is you're alone in the parking lot and you walk towards your car, and then a strange man will appear and approaches you. So what will happen is the following. The first is you see the strange man appearing, then your heartbeat will start to race and you're trembling, and then this rapid heart rate and trembling will be caused by fear. That's a cognitive labeling. And then you conclude that you're frightened. And then our final theory of emotion, it comes from the 1980s. So this is also called the cognitive appraisal theory. And appraisal is actually when you try to think about what does this actually mean. So first we have a primary cognitive appraisal. What does this mean? And then you can conclude that maybe this is not important, or this is good, or this is very stressful. And then you have a secondary appraisal, which can either be positive appraisal. I can do this if I do it my best, or if this fail, I will just try another method. Or you can have a negative appraisal. I can do this. I know I will fail. I won't even try my chances because they're too low. So for example, you see a bear in the woods and your primary appraisal can be, this is very stressful. And your secondary appraisal can be, but I can actually escape. Now, when we know some basics about what emotions actually are, then we can go into how do we actually measure emotions. So to find the origins of this, we have to go back to the late 1800s. So here we had Charles Darwin. He wrote a book called The Expression of the Emotions in Man and Animals. And in this book, he claimed that emotions are universal across the human species. And around the same time, in 1860, we had the French physician called Duchenne. So what he did was he wanted to study facial expressions and how the facial expressions relates to emotions. So what he did was that he took photographs of his patients, and what he did was that he used some probes with some weak electricity that he induced into the face of his patients. And then he caused the face muscles to contract, and then he could provoke different types of expressions. And then he published this in a book where he could identify 60 discrete emotions, so mapping them from a photograph to an emotion. And if we fast forward another 100 years, we have an American psychologist called Paul Ekman. He did studies regarding facial expressions and emotions. So he wanted to investigate, is that a universal relation between these two things? So he traveled to Papua New Guinea to study facial expressions, And he selected an isolated tribe, and he found evidence that facial expressions and emotions are actually universal. And he developed something that we call the Atlas of Human Facial Expressions. And he developed this standardized set for how we can study facial expressions that you can see here on the slide. So this is showing us the different types of micro expressions that we have when we express an emotion. And this is still used today when we do behavioral and user studies. But how can we do then to detect emotions? So there are three main ways for detecting emotion. The first one is to study the face, facial and bodily expressions. So in this picture you can see this what we call universal emotions. And the second way is to study the speech. So we can study the tone, the intonation, the pausation and the rhythm. And the third way is to use physiological based measures. It can be the EEG or the heart rate or, for example, skin conductance. So now when we know a little bit about emotions and how can we actually detect emotions, then we can go into affective computing. So affective computing started in the 1990s by a researcher at the MIT Media Lab called Rosalind Picard. And she published a book called Affective Computing. By doing so, she started up a whole new field of research, which now has its own IEEE proceedings, as well as international conferences and multiple research groups all across the world. And what she said in her book was that we should be able to use machines in order to understand our emotions. So the machine should be able to sense the emotional state of its user. So it should use sensors, cameras, and microphone, and use speech recognition, gesture recognition, and image recognition to do so. And it should use machine learning algorithms in order to make sense of all of this data. But we have to take into account that this was in the 1990s, so a lot of these things were not so developed as they are now today. So basically, we can ask ourselves, why is machine learning and AI, why they are such a hot topic today, and why do we have so much progress in it? So there are some enabling technologies for that, and one of them is that we have access to smart sensors that can enable real-time data flow. We're also able to handle all of this large amount of data, both storage and to process, to do transformation and so on. And we have machine learning algorithms running in the cloud that we can also use. And thankfully for us as developers, there are services that we can use straight out of the box in order to integrate them into our own products. I'm going to give you a couple of examples here of these types of services. So the first one is called the Face Detection API, which is from Microsoft Cognitive Services. So how this function is that you send in a picture and then you will get an emotion rating back. And Microsoft is not alone in having this. So for example, Amazon has something called the Amazon Recognition, and IBM has the Emotion Analysis API. But now, today I'm going to give a quick demo here how you can set up this face detection. So let me switch over to the browser. Now we're inside the Azure portal, and then what we do here is we just create a new resource, and we search here for face, and we can create a new face resource. So we just decide the resource group and the region and the pricing tier. And then what we get after that is we can use a test console that Microsoft provides us with. And in the test console, we define here what is the resource that we want to use. And then in order to get this emotion ratings back, we need to provide here that return face attributes, which is emotions. And then we provide them with our subscription key. And then after that, we can provide them with an URL to an image. So I have a couple of images. Let me switch quickly over to that. One more. So over here we have this image of this boy here, and then we're going to provide our API with that image. So let me copy the URL, and then let's go over to the console and let's Let's issue a request here, and then the first thing that we get a face rectangle back. So that is where the machine learning algorithm has detected that there is a face in this picture. And then after that, we get some facial attributes, and this is the emotion ratings here. And then we can see that with 83.2% probability, this person on the picture is experiencing surprise. We have also another picture. Let me just switch over to this. So here we have another picture that we can use, and then like that, and then we push send. So here we also get the face rectangle, and then we can see with 93.2% it's experiencing disgust. But there can also be, maybe there are multiple people inside the picture. So how does our algorithm handle that? So we have another example over here. So let's provide this into the face API, and so then we can see here that now we get two face rectangles, and with its own face ID, and the first one is surprised by 19.7%, and then the second one is surprised with 86.2%. So this was just a quick example here on how you can actually make use of pre-built functionality in the Microsoft Cognitive Suite in order to include some emotion analysis in your own applications. And I would also like to do a quick demo here of sentiment analysis. So sentiment analysis, you use that when you have a large amount of text and you want to try to get some kind of understanding on what kind of emotions are expressed in this text. So it could be, for example, if you have a business where you have lots of reviews and you want to have an overall understanding of are they mostly positive or mostly negative. So let's switch back to the Azure portal, and then we can create a new resource here. We can create a new cognitive services resource. And again, we just decide the resource group and the region and the name and the pricing tier. And then we also have a text analytics console that we can use. So we define the resource name, and we define the subscription key. And then over here we have two reviews here for a restaurant here. So the first is, it's a great atmosphere, close to plenty of restaurants, hotels and transit, and staff are very friendly and helpful. And we have a second review where they say it's a bad atmosphere, not close to plenty of restaurants, and staff are not friendly and helpful. So if we send this into our sentiment analysis, then we get the document back here where we can see that for the first document, it gets an overall sentiment of positive, and then it goes into detail here for each sentence in that first review. So great atmosphere, for example, gets a positive review. That is close to plenty of restaurants, gets a neutral sentiment, for example. And then for a second review, it gets an overall sentiment of negative, and then also goes into detail here for the first sentence, bad atmosphere is negative, and so on. That's also an example of how you can use emotions, how you can determine emotion facts in your solution. So I'm going to give you some application scenarios how this can be used. The first application scenario is within retail. So in retail, you could have a store equipped with cameras that can register the facial expression of customers, and they can determine the emotions of the customers. And the staff can use this information to enhance their service and give a better experience to the customer. Then we also have within the medical field. So in the medical field, you could use physiological-based measures to determine the patient's emotional state, and you can be able to reduce stress, among other things. And the medical team can be able to respond much quicker to the needs of the patient. Then you have inside education, the teacher could use cameras to detect the emotions through the facial expressions of the students. So if the majority of the students are feeling bored, then the teacher could change his method of teaching. And this could also be applied in an online setting where we can make use of the web camera in order to measure the emotions of the remote students. And we also have an example here from the social sphere. So one big problem here in a large part of the Western world is that we have a growing population of elderly people, but we don't have enough of workers that can aid them in their daily life. So in Japan, they have made experiments using robots that can socialize with these elderly people. So these robots will use both facial recognition, speech and tone evaluation, and also physiological measures to adjust the robot's behavior towards the elderly people. So I would like to take an example here of what is in the front line. So there's a company called Affectiva that stems from the MIT Media Lab. And what they say that they have the world's largest emotion database. So they have 6 million faces across 87 countries. And what they do is they offer an emotion SDK and API so that we as developers can integrate their technology in our own products. And some examples of use case where this has been used is, for example, virtual assistants, where you can recognize the emotion of the user. Or you can think of a personalized transportation experience. So you have a self-driving car that can adjust both the route and the music and other things according to the moods of the passengers. So if he finds out that the passengers are in a good mood, he can adjust and maybe take the scenic route and play some good music. But if he finds out the passengers are in a bad mood, he will probably just take the shortest path between 2 points. And this has also been used in advertising. So in advertising, it's important to be able to understand exactly at what point an advertise creates the right emotion. So you need to find out so that the advertise will create the right emotion at the right time. And then you can use technologies such as this for that. And it has also been used in cars. So in order to do head, face and head tracking so that you can detect if a driver start to get drowsy, then you can issue an alarm so that he doesn't fall asleep and cause a traffic accident. And I would also like to introduce Pepper to you. So Pepper is a robot developed by SoftBank Robotics, which is a Japanese company focusing on making robots that can adapt to humans. And Pepper was introduced in 2015, and he determines the emotions of the people around him by utilizing voice and face recognition, as well as body movements. And he responds by changing the color of his eyes, the tone of his voice, and also the content that is displayed on his tablet. And it's been used in both in large banks in Japan, in Nescafe stores, and also in the railway stations in different places in Japan. And as a fun fact, Pepper is, as of August 2018, he's using the Affectiva API for emotion recognition. And I would like to talk a little bit here about artificial general intelligence. But before I do that, I will just take some to drink. So artificial general intelligence, that means when we could have a machine that can perform any intellectual task that a human can do. And that is opposed to what we have now, which is called narrow intelligence. So with narrow intelligence, the machine learning algorithm can only solve a specific problem or a specific reasoning task. But how do we know when we reach this AGI, artificial general intelligence? So there are some operational definitions that I will describe to you. So the first one is called the Turing test. So it was first described in 1950 by Alan Turing, and it has many different types of interpretation. But the one that I'm going to take is from the 1990s. So it's called the Loebner Prize competition. So here a program will win $1 million if it can fool half the judges into thinking it is a human while interacting with them in a free-form conversation for 30 minutes and interpreting audiovisual input. And then we have something called the coffee test. So the coffee test is if the AI can go into an average American house and figure out how to make coffee. And this includes identifying the coffee machine and figuring out what the buttons do, and also finding the coffee in the cabinet. And the third operational definition is called the robot college test. And this is when a robot can enroll in a human university and take classes in the same way as humans and get a degree. And the fourth one is called the employment test. And this is when machines are exhibiting true human level intelligence and can be able to do any kind of things that humans are able to do. So what does this mean, for the future? Is the future a threat or is it a hope? So let's have a look at what people have said in the past. So first up, we have Elon Musk. He said that with artificial intelligence, we are summoning the demon, that AI is our biggest existential threat. And we also have Stephen Hawking. He said that development of full artificial intelligence could spell the end of the human race. It would take off on its own and redesign itself at an ever-increasing rate. Humans, who are limited by slow biological evolution, couldn't compete and would be superseded. So these guys said this in 2014, but there are people who said things further back in the past. So let's have a look at what they said. So I have Marvin Minsky, who is one of the fathers of AI. He said in 1970 that once the computers get control, we might never get it back. We should survive at the sufferance, and if we're lucky, they might keep us as pets. And this was some 50 years ago, but this hasn't really happened yet. And around the same time, we have two other researchers, Newell and Simon. They said that symbol systems modeling human problem solving is the answer. We better alert the people. But they didn't really need to alert the people. And around the same time in the 1980s, there was something called rule-based systems. So two other researchers, they wrote a book where they said that Japan will dominate the world because they are using these rule-based systems. But that did not happen either. So the question is, when will we reach this state of human level intelligence, and will this be bad or will it be a good thing? So we can have a look here at some research that Max Tegmark, he's a researcher at MIT, he sent out a survey to the leading research community within machine learning and artificial intelligence. And he was asking them two things here. When will artificial intelligence surpass human level intelligence? And if that happens, will it be a good thing or will it be a bad thing? And then we can divide the research community into a number of groups here. So first, if you ask them, will this happen in a few years, then that's virtually nobody that thinks that. And you can also ask, will it happen, in a few decades or up to 100 years? And then there's a group that thinks this, and you can divide this into three subgroups. You have the Luddites, which thinks that this is definitely a bad thing. And you also have the digital utopians, which think that this is definitely a good thing. And then you have what we can call the beneficial AI movement, which are somewhere in between. And then you have some people that thinks that this will probably happen maybe in 100 years or in 300 years, or maybe it will never happen. And we call these the techno-skeptics. So we can see here that even though these are leading researchers that are working full-time in the front line, not even they can say with any certainty, when this will happen, or if it will be good, or if it will be bad. But that doesn't mean that we should neglect this thing. So I think it's important for us to realize that these type of technologies is already existing, and take action now here and start to think about what should be allowed and what should not be allowed. So that leads us into ethical AI. And one standard problem here within ethical AI is called the moral machine. And this is a test or a survey that's been developed by the MIT Media Lab. So it was launched in 2014, and by now there are millions of people who have taken this test. So what the test is talking about is that you have a self-driving car that is approaching a zebra crossing where there are people crossing. And then the question is, what should the self-driving car do? Should he prioritize humans over pets, or passengers over pedestrians, or maybe more lives over few lives, women over men, young over old, fit over sick, maybe high social status or law abiders? And it could also be, should the car actually take action or not? And what they found in this study is that the answers to all of these questions, they vary a lot on the basis both of culture, of economics, and on geographic location. So should I quick look at some of these answers to this question? So here are the answers to if here we can see that countries with more individualistic culture are more likely to spare the young people. So for example, United Kingdom and United States, as opposed to Japan and China. We can also see that countries with more individualistic cultures are more likely to spare more lives than fewer lives. So here we can also see United Kingdom and United States, as opposed to China and Japan. Or should we spare pedestrians over passengers? And here's a big difference between Japan, for example, and China. So what this means for us is, if we can see that there is no, objectively, morally right thing to do for us as humans, then how can we then expect that an artificial intelligence should be able to reach that kind of state? So you can see that this is varying a lot. So what is important is that we take this into account both when we use machine learning algorithms and when we develop these algorithms. So one tool that we can use in order to try to make these things more fairer for us to use is called fair learn. So one challenge today is that AI can treat people unfairly. And we have to realize that fairness is actually not only a technical challenge, but it is a socio-technical challenge. So that means that when we have our data sets, there will be societal basis in our data sets. And the same thing when we develop and deploy machine learning algorithms. So some examples on what this can lead to is, for example, if you have an automated resume screening system, then women are underrepresented in tech, and that can lead to that there will be fewer employment opportunities for women. Or you have a facial recognition system, and maybe it will not recognize people with a particular skin tone because it hasn't been trained on that. Or you can have a machine translation system. So if you use a gender-neutral language, like for example Turkish, and you translate the sentence that someone is a nurse, then it will automatically be translated to she is a nurse. Then we can use fair learn in order to correct these things. So there are two basic problems here that we can have a look at. One is something that we call the quality of service harm. An example here is that you have a voice recognition system that might fail to work as well for women as it does for men. Then we have another that we call allocation harm. And this is, an example here is that you have a system for screening loan or job applications, and it might be much better at picking good candidates among white men than among other groups. So we can use fair learn here. So fair learn is an open source toolkit that you can use. So if you use it, you will have access to a visualization dashboard. So let's say that you have an algorithm that will decide if you will be allowed to take a loan or not. And then you want to see if there is a problem here with fairness between men and women. So you can load your data set and you can start up the fair learn dashboard. And then you can define which feature would you like to evaluate. So here we select sex because we want to see if there is a difference between men and women. And then you decide what is the performance. So we choose accuracy as our performance measure. Then we will get a visualization dashboard where we can see here, if we look at the right-hand side, where we say disparity in predictions. So then we can see that on the whole population, then the people that will be allowed to have a loan is 16.4%. But if we only look at the male population, then there will be 21.4% of males that will get the loan. And if we look at female, it will only be 6.35% of that. So here there is a disparity challenge for us. But what we can do is we can use fair learn in order to correct this. So we can retrain our model, and by using some inbuilt functionality in the fair learn, what that fair learn offers us. And then we can run this again. And then we can see here that on the left-hand side, we have our mitigated model, and on our right-hand side, we have our original model. And we can see that we have to sacrifice some accuracy. So we go from 0.845 to 0.82. But on the other hand, we can see that we have reduced the disparity from 0.16 to 0.02. So if we are, if we're fine with that, we can use this mitigated model instead. Fallon is actually integrated with Azure Machine Learning, so you get it just as one of the tab when you run an experiment in Azure Machine Learning. But it's not limited only to that. So you can just use it in a regular Jupyter notebook and just do pip install in order to use Fallon. So now I've come to the end of my presentation here, so I'm going to talk a little bit about collective intelligence. So collective intelligence is nothing new. It's been known for a long time that a group of people have a higher chance of achieving great results than a set of individuals. So there was some research that they set out to try to find, is there a single factor that can be found that we can call collective intelligence? So their first idea was that maybe it's correlated with the individual IQ of the people in the group, but they only found a moderate correlation with that. Instead, they found 3 other factors. So the first factor is something that we call average social perceptiveness. So social perceptiveness is a test that you can do yourself. It is online. So basically what it is that you will get an amount of pictures where you can only see the eye portion of a person. And then you should be able to read the emotions just by studying the eyes. And then the second factor is called participation in group conversation. And here it's important that you don't have any dominant person in the group. And the last factor is called the proportion of women in the group. The more women, the more intelligent groups. And that goes back to this social perceptiveness. So what this means for us here is that we as individuals, we need to be good at working together. We need to have good interpersonal skills. And for computers, we need to design computers that can work well with people. And this is an important area for effective computing. So finally, I have some references. So I hope that you found this interesting and you want to learn about this more. So then I can recommend these books here. So the first book is the Affective Computing book by Rosalind Picard that started everything. And then we have a book called Blueprint for Effective Computing by Klaus Scherer and Tanja Bensinger. And we have also the Oxford Handbook of Effective Computing by Calvo, De Mello, Gratch, and Kappas. With that said, I would like to thank all of you who were tuning in to this presentation. And if you have any comments or questions, you can always reach me on Twitter. So my Twitter handle is Gravlis, or you can reach me on this email address that you can see here on this slide. So thank you so much, and I wish you a great conference ahead.